All right, today we're diving into something incredible. Stealth technology, the invisible weapon. We're going to peel back the layers on one of the most game-changing developments in the history of warfare. Just think about that for a second. For decades, it was pure science fiction. But then, some absolutely brilliant, radar-defying innovation made it a reality, creating an invisible weapon that totally rewrote the rules of modern combat. So we're going to trace the journey of this mind-blowing tech, from its earliest, almost forgotten concepts to its massive impact on the battlefield, and into the constant, high-stakes race to stay one step ahead. Let's get into it. The whole story of stealth really kicks off with a massive problem. How do you survive in a sky that's just blanketed with enemy radar? Well, the answer didn't just appear overnight. It was a long, fascinating, and often frustrating quest for invisibility.
You know, the road to stealth was, well, it was long, and it was full of trial and error. As you can see here, the first attempts sound like something out of a comic book. Back in World War I, Germany tried wrapping planes in a transparent material called cellophane, but, the sun glinting off of it actually made them easier to spot. Oops. Then in World War II, you get this radical design, the Horton Ho 229 Flying Wing, a plane so far ahead of its time, we're still debating its stealth capabilities today. The real push, though, came after the war, but the first radar-absorbing materials were just way too heavy to be practical. The real game changer finally arrived in the 1970s with lightweight carbon fiber composites. That's when a true stealth combat aircraft finally became possible.
Okay, so how in the world do you make a multi-billion-dollar aircraft just vanish from a radar screen? Well, it all boils down to two fundamental ideas that completely flipped aircraft design on its head. First up is shape. A normal airplane, with all its curves and right angles, is basically a perfect mirror for radar waves. It bounces the signal right back to the antenna that sent it. Stealth aircraft, on the other hand, use all these weird angled surfaces to scatter those radar waves in every direction except back at the source. The second key is the material. The plane is literally coated in special radar absorbent materials, or RAM. Think of it like a sponge for radar energy. It soaks it up and turns it into a tiny amount of heat instead of reflecting it.
And all of this brings us to a really key idea, radar cross-section, or RCS. Basically, it's a measure of how big an object looks on a radar screen. A regular bomber might have the RCS of a school bus. The whole goal of stealth is to shrink that signature down to the size of a bird, or maybe even a golf ball.
And this is what you get when all that theory comes together. In 1977, Lockheed's top-secret prototype, called Have Blue, proved the concept actually worked. Fun fact, its pilots nicknamed it the Hopeless Diamond because it was so ugly and unstable to fly. But it was the direct ancestor of the world's very first operational stealth aircraft, the legendary F-117 Nighthawk.
Okay, so having a stealth jet in a secret hangar is cool and all, but what happens when you unleash it on a real battlefield? Let's take a look at how this technology absolutely changed everything once it went to war. Let's put this into perspective. During the first Gulf War, the F-117s, they only made up about 2.5% of the American aircraft in the region. Think about that, a tiny, tiny fraction of the total force. And yet, those few jets were responsible for hitting an incredible 40% of all strategic targets.
And here's the bottom line. Stealth gave military planners an advantage they had only ever dreamed of. Suddenly, they could send planes deep into the most heavily defended territory on Earth, like right into downtown Baghdad, and take out critical command bunkers and air defense systems without any resistance. The enemy literally had no idea they were even there until the bombs started exploding.
But here's the thing, right? Being invisible to radar, that's only one part of the puzzle. Modern weapons are designed to hunt for targets using every trick in the book. So, to be truly stealthy, you have to hide from every single sense.
Radar might not see you, but what about sensors that see heat? Every jet engine is basically a furnace, right? It's a massive, blazing beacon for any missile that's designed to lock onto an infrared signal. And this image, wow, it shows the problem perfectly. That bright, glowing plume of hot exhaust is like a giant neon sign screaming, "Shoot here!" for heat-seeking missiles. So, to be truly stealthy, you have to find ways to cool down those exhaust gases and shield all the hot engine parts from view. And it's not just planes anymore. These ideas are everywhere. The Navy's USS Zumwalt destroyer uses that strange angular hull to deflect radar. Stealth helicopters use these incredibly complex exhaust coolers. Advanced drones like the RQ-170 are built from the ground up to be sneaky. And we're even seeing concepts for tanks with hybrid engines to cut down on their heat and noise on the battlefield.
Which brings us to where we are today. And honestly, it's this constant high-stakes game of technological cat and mouse. For every brilliant new way to hide, there's another team of brilliant engineers working on a new way to find you. It never stops.
You just have to look at how the aircraft themselves have evolved. That first-gen F-117 was an absolute marvel. But let's be honest, it was unstable, it was slow, and its delicate radar-absorbent skin was a total nightmare to maintain. Now compare that to today's fifth-generation fighters, like the F-22 and F-35. They combine stealth with insane maneuverability, the ability to fly supersonic without even using their afterburners, and much, much tougher materials.
And you know the secret's out. For a long, long time, the US was the only player in this game. But today, both China, with its J-20 and J-35 jets, and Russia, with its Su-57, have their own operational stealth aircraft. It's become a global capability.
So, what about the other side? How do you find something that's designed to be invisible? Well, engineers figured out that since stealth planes are shaped to beat specific radar frequencies, you might be able to spot them with other frequencies, like longer wavelength VHF radar. And the latest infrared sensors are now so sensitive they can potentially track the heat generated by just the air friction on a plane's skin. There are even clever new systems that use multiple radar receivers in different spots to catch those scattered reflections that a stealth aircraft is trying to throw away.
So from those wild early experiments with transparent coverings to today's fifth-gen fighters locked in this digital arms race, the story of stealth proves that sometimes the most powerful weapon really is the one you can't see. But it leaves us with this huge question for the future. In a world of smarter sensors and interconnected networks, is true invisibility even possible anymore? Or is this race between hiding and finding just destined to go on forever?